We are about to solve an equation containing a radical expression. Make sure, if possible, you isolate a radical expression and then you remove the radical expression by either squaring both sides or cubing both sides, depends on the index. Also, don't forget that for radical equations, that is, equations containing radicals, we need to check every possible or proposed solution in the original equation. So let's look at our equation. X equals the square root of x minus 2 plus 2. Don't forget what I mentioned. If possible, isolate a radical. We will isolate this radical. So I'll subtract 2 from both sides, and that's x minus 2 is equal to the square root of x minus 2. Now, once this radical, in this case, is isolated, we want to remove it by using the power rule. I will square both sides. I'll square the right side, and because I squared the right side, I must also square the left side. Now, here's a common place where mistakes occur. Here you are squaring a binomial. Don't forget that's x minus 2 times x minus 2, and if you need to go off to the side to square that, please do so. But in squaring, that is x squared, and you do have a middle term, minus 4x plus 4 is equal to the square root of x minus 2, that quantity squared, gives me that radicand x minus 2. Now you need to look at this equation and decide what type of equation you now have. We have a quadratic equation, so we will set it equal to 0 and try and solve. That is x squared, and that's negative 4x minus x, so that's negative 5x. 4 plus 2 is plus 6 is equal to 0. Let's see if this factors using the zero factor theorem. So that's x and x. 2 factors of 6 whose sum is negative 5. That'd be negative 2 and negative 3. Make sure you check my factoring, but it is correct. Then remember, we set each factor equal to 0 and solve. Here x is 2, here x is 3. So notice we have 2 proposed solutions, and for radical equations, those proposed solutions must be checked, and they must be checked in the original equation. So I'm going to check these separately. Let's check 2. How do we check? Everywhere there's x, I write 2. So is 2 equal to the square root of 2 minus 2 plus 2? Well, is 2 equal to, that's the square root of 0, which is 0, and 0 plus 2 is 2, so 2 checks, it is a solution. Now let's check our other proposed solution, which was 3. Everywhere there's x in the original equation, we'll replace it with 3. Is 3 equal to the square root of 3 minus 2 plus 2? So is 3 equal to, the square root of 3 minus 2 is 1, square root of 1 is 1, and I have 1 plus 2, and that is, of course, 3. So that's a true statement. Both of these check, and both of these are solutions.